Okay, this is section 6.6. We're going to talk about simplifying expressions, which we've been doing, but it's going to get even more complicated. In order to do these, you must know all your exponents rules. So the product rule of x to the m times x to the n equals x to the m plus n. The quotient rule, x to the n divided by x to the n is x to the m minus n. The power rule, x to the m raised to the n is x to the m times n, and x to the negative is 1 over x to the first. Okay, so you can't forget these rules. You're going to have to know these. Also know radicals and fraction rules. If you're very weak on any of those, you're going to struggle with it. So that's the key to successfully doing these kind of expressions. So you see they look a little different. Look at this first one. B to the 1. So we're talking about radical form and exponential form with rational expressions. What does rational sound like? A ratio. What's a ratio? It's just a fraction. So we're saying fractions. So if you have base b to the 1 over n, this is your exponent. The denominator, n, is your index, and 1 is your power of b. So b to the 1 over n is equal to the nth root of b to the first. So the general formula or property is if you have b to the m over n, it's equal to the nth root of b raised to the m power. All right? Now, radical form is when you have a radical sign. So it's written, that is radical form. Exponential form is when you have an exponent. All right, so know the difference. Exponential form, radical form. That's all that is. So all the properties of powers apply to rational expressions. You have to write each expression with all positive exponents. Any exponents in the denominators of fraction must be a positive integer, so it can't be a fraction, which means you have a radical sign. It may be necessary to rationalize the denominator because you cannot have a radical sign in the denominator. So you've got a million concepts that you probably are not real strong in. You might be a little weak and it might seem complicated, but break it down and say, go back and look up these rules. What do these rules say? So let's look at example 1a. It says, write this in radical form. So we said this is in, how can we move this to the numerator? Can't we rewrite this using exponent, say negative x to the negative? Oh, this is one, I'm sorry, got this wrong. It's x to the 1/6. So this is an exponential form. Remember we said x to the m over n is equal to the nth root of x to the m. So we're going to have a radical sign because we have an exponent as a fraction. So that's the first thing. What's our base? X. What's our index? It's the denominator, 6. What's our power of our base? 1. So this is the 6th root of x. Let's do another one. The 4th root of z. All right, so then I want you to write this in exponential form. So what's our base? Z. We're going to have a fraction because of a radical sign. What's going to go in the denominator? That's our index, 4. What's the power of z inside? 1. So this is written z to the 1/4. All right. Now they want us to evaluate 81 to the negative 1/4. Well, first, let's write this in radical form. First of all, let's get rid of this negative. So that's going to be 1 over, this is knowing exponent rules, 81 to the 1/4. Remember to change the sign of the exponent. Don't let, because it's a fraction, scare you. That would be like if I had 81 squared or 81/3. So let's look at it that way, and then we'll go back and use the rational rules for this. All right, so we've got it positive. Now, what does that mean? 1 over, we know we're going to have a radical sign because it's a fraction. The base is 81. My index is 4, and my exponent is 1. And how do I simplify that? Well, what is 9? 81. It's 1 over the 4th root of 3 times 3 times 3 times 3, or 3 to the 4th. Remember, my index is 4. I have to have 4 to take 1 out, so my answer is simply 1/3. So there's a lot of things going on here. Don't get confused. Let's do another one. Evaluate 216 to the 2/3. Well, we need to make sure it's positive. It is. If it's negative, we would take the base of 216 over 1 and change it to its reciprocal. But it's positive, so we don't need to do that. So we have a fraction, so I'm going to have a radical sign. My index is in the denominator of 3. My base is 216, and my exponent is 2. So I need to know, this is the same thing as saying the cube root of 216 times 216, because isn't that what 216 square means? So I need to prime factor it out. If I don't have a calculator, 108, 2 times 54, 6 times 9, 2 times 3, and 3 times 3. So what I have is I have the cube root of 1, 2, 3 twos, 2 cubed times 3 cubed, and then I have 2 of them, so I have it again. I've got to have, so I can take 1, 2 out, 1, 3, 1, 2, and 1, 3. There's nothing left, so this goes away. So if 2 times 2 is 4 times 9, so my answer is 36. So a lot of stuff going on here. A lot of different rules. Know these rules and break it down one by one. All right?